Okay, and then submit. And then let's do another one. Oh, let me clear all my annotations. Okay, so we just did basic exponent rules. Let's do exponential and radical form. So we're going to write the expression in radical form. We have x to the power of 2/5. So the base, the x, that's going to go inside your radical. Then I'm going to try to circle it. That wasn't really circled. There you go. That 2, that's going to stay over here as an exponent. And then the 5, okay, that's the best circle I can do. That 5 is going to go right here as your radical number. So we want the 5th root of x squared. All right, so let me type that out here. So since there's a number here, I'm going to use this one, this button. And then I'll type my 5. I'll go inside here, type x. And then to type squared, you can either use their keyboard if you forgot how to type it. And you can use squared like that. Otherwise, you can use Shift 6 to type any exponent you want. But okay, so for this one, are there any questions? I'm going to pause the recording. All right, let's do simplifying radicals guided. Okay, let me clear my annotations. So we're going to go step by step to reduce this radical. So when you're reducing a radical, you want to think about what perfect squares can fit into 162. And so if you forgot what a perfect square is, that's like, well, 1 squared is 1. That's going to fit into any number. That one's not that important, but it's still a perfect square. Then there's also 2 squared, which is 4. So 4 is a perfect square. There's also 3 squared, so 9. So 9 is a perfect square. There's also 4 squared, which is 16. So 16 is a perfect square. 5 squared, which is 25. So that's a perfect square. And I could keep going. Like 6 squared is 36. So 36 is a perfect square. So all of these numbers and so on and so forth are perfect squares. And we need to think about which of these will fit into 162. So is 162 divisible by 1, 4, 9, 16, 25, 36, or numbers like that? So off the top of my head, I don't immediately know, which is totally fine because you have a calculator. So you can use a calculator and do 162 divided by, let's say 9. Let's say I think it's divisible by 9. And it is. And all I did was just 162 divided by 9, and it gave me 18. I was just guessing. I like literally just picked any of these numbers. Just pick a number and divide it, and make sure you just get a whole number. If it says like, oh, let me just try one that wouldn't work. 162 divided by 4. Let's just say I try 162 divided by 4 because 4 is a perfect square. And then it gave me 40.5. I'm sorry, that's really squishy. It gave me 40.5. So notice 40.5 has a decimal in it. So since it has a decimal, you don't want that one. You want to look for it where when you divide it by the perfect square, you get a whole number here. So I did. 162 divided by 9 gave me a whole number. And so I'm going to put the perfect square in the first box, the 9. I'm going to put the 18 that left over in the second box because 9 times 18 gives me 162. And then I press try. And then if you did it wrong, it wouldn't simplify. It wouldn't go to the next step. But if you did it correctly, then it'll move you on. Okay, so after this, we need to just simplify square root of 9. So the square root of 9 is 3 because 3 squared is 9. So the square root of 9 is 3. And then the square root of 18 just stays as the square root of 18. So all we did was simplify the square root of 9 here. I'm going to press try. And then notice we have 2 more radicals, which means we're going to have to do something with the square root of 18. And what do we do with it? We're going to think which perfect squares fit into 18. Is it 1? Is it 4? Is it 9? Is it 16? Is it 25? Is it 36? Which of these can be multiplied by something to give you 18? And so I'm going to put 9 times 2 equals 18. And I choose 9 because 9 is a perfect square. I'm not going to choose some random number like 6 and 3 because 6 or 3, both of those are not perfect squares. Even though 6 times 3 equals 18, we're choosing from the perfect squares list, okay? You don't just choose something random. You got to choose from your perfect squares list. So I got square root of 9 times square root of 2 equals the square root of 18. I press try. And it looks like it works so far. And so we're just going to have to simplify the square root of 9 again, which is 3 again. And then the 2, just bring it down. Just keep it in your radical. I'm going to press try again. And then we're in our last step. The square root of 2 just stays as the square root of 2. And in this first box, you just want 3 times 3. I was just trying to highlight those two, but yeah, 3 times 3 gives us 9. So we have 9 square root of 2. And press try. And it says you are done. You may press submit. So for this type of problem, when it says you are done, you know you got it correctly because it's only going to let you go through if you did it correctly. Okay, let's do another one. So we just did that. Let's do geometric to exponential function. Okay. I believe for this one, we all have the same problem. So you might want to just look and do it together with me because I think we have the same one. So this one says convert this geometric equation to an exponential function. So we're going to do exactly that. Remember these rules: split, flip, multiply, replace. These are the rules that we had in our lessons like a long time ago. And so we're going to follow those rules. So the first step is split. So what are we splitting? We're going to split this n minus 1 into, well, I'll just show you. We have g sub n is equal to 8 times 2 to the power of n. And then now I'm going to do the splitting portion. So it's times 2 to the power of minus 1. So notice that the 2, the base, gets repeated twice, 2 and a 2. And then the n minus 1 gets split into the n and into the minus 1. So remember, like I said, we all have the same question for this one. So you should probably just, look at it, write it down. So that's the split step. We split the n minus 1. The next step is to do a flip. So I'll do that mostly in purple, and then I'll show the flip in red. We have g sub n is equal to 8 times 2 to the power of n. Okay, here's the part where you flip. So 2, like this 2, is a whole number, and whole numbers are technically fractions. Everything you see can technically be a fraction because 2 is the same thing as 2 divided by 1. So technically, 2 is 2 over 1. And so that fraction, the 2 over 1, is the thing we're going to flip. And so now instead of 2 over 1, it's now 1 over 2. And that takes care of the minus 1. So when something is raised to a negative 1 as their exponent, that just means flip the fraction. So now instead of 2 over 1 to the power of negative 1, we have just 1/2. And so we now used up the negative 1. You don't have to write the negative 1 anymore. The 2 over 1 just flips into 1/2. And for the next step is multiply. So I'm just going to kind of scoot it down a little bit. What are we multiplying? So let me rewrite things in purple first. Okay, the things you are multiplying are the 8 and the 1/2. So essentially, what is 8 times 1/2? You can use a calculator if you like, but 8 times 1/2 is the same as 8 divided by 2, which is 4. So I multiplied those two blue things that I circled. And then the times 2 to the power of n doesn't change. So multiply is multiplying the 8 in the front and the 1/2 in the back, and you get 4. And finally, for replace, let me just write that as the last step. Actually, what color should I use for this? I'll use green. Okay. So for replace, you're just going to have f of x instead of the g sub n. So this g sub n just got replaced by f of x is equal to 4 times 2 to the power of, that n right over here gets replaced by an x. So that looks kind of like a t. Let me write it a little better. X Okay, so finally your equation is just f of x is equal to 4 times 2 to the power of x. So the g sub n got replaced by f of x in the front, and in the very back, the n got replaced by x. So it's just literally switching out letters for the replacing step. So on the answer box, it already gives you the f of x, so you don't have to type that. But I'm going to type the 4 times 2 to the power of x. So 4 times is shift 8. Shift and 8 gives you the multiplying sign. 2 to the power of x. And to type an exponent, you do shift and 6. Shift 6 gives you the exponent typing. So now I have typed 4 times 2 to the power of x. Are there any questions? And let's submit this. Let's go back. Let me erase all of that. It just bothers me. Okay, so we just did geometric to exponential function. You can do that one on your own. Now let's do common ratio, y-intercept, and asymptote. So for this one, there's a couple ways you can do it. There's the graphing way, and there's the just look at it way. I'll do both for you because it just depends on the person which one's better for you. Might be worse for someone else. So we'll do both. So we're going to find the common ratio, the y-intercept, and the horizontal asymptote of this exponential equation. You can use a scratch paper to make a t-table if you find it helpful. Hint, the horizontal asymptote is an equation. Okay, so we're given this f of x is equal to 2 times 4 to the power of x equation over here. And I'm going to rewrite this as just saying that there is a plus 0 here, because technically if I add 0 to something, I didn't change anything. Like if I don't give you anything, just like me adding zeros, giving nothing. If I don't give a person anything, they are exactly the same as they were before I just stood there in front of them. Okay, so 2 times 4 to the power of x plus 0 is our equation. The common ratio, I'll underline it, is the number at the base of the x. So it is the 4. The y-intercept, sorry, I'm just changing colors. Takes a while. The y-intercept is 0, comma, the number that's in front of the equation. So 0, comma, 2. And I'm going to type that in. And finally, the horizontal asymptote. For a horizontal line, you want to write an equation. A horizontal line would be y equals some number. So what is that number? It's going to be the number at the very end. So if it's plus 0, then my equation should be y equals 0. And so that is your horizontal asymptote. Okay, so I promised you 2 ways to do this. So here's the first way. I'm also going to go to Desmos. I'm just going to leave these markings here because why not? Okay, I'm going to type my equation. F of x is equal to 2 times 4 to the power of x times 4 to the power of x. Okay. And I get this line over here. So the common ratio, you can't really see it in the graph. So the common ratio, you still have to know it's the base of the x. So the common ratio is still the 4. The y-intercept. So for the y-intercept, if you just graphed it out, the y-intercept is what appears where the graph intersects this axis. So you can see right here, 0, 2, which, like we said over here in Delta Math, was just the number in the front, is the 0, 2. That's your y-intercept. And finally, for the horizontal asymptote, you still have to type y equals. Okay, but what number is it? If you were to look on the graph, you see how it looks really flat over here? So if you just hover your mouse over it and you just click and drag, you can see that the x value changes, but the y value stays at 0. And so that's why the equation is y equals 0, because it's going to be 0 for like all of these numbers. Look how the 0 has not changed. So that's how you can tell from a graph. And this is how you can tell from the equation. The 0 is right here. It's the thing that's added at the end. Since there's nothing added at the end, it's a plus 0. So the equation is y equals 0. Okay, let me erase my annotations. And then now we are on to transform functions mix, level 1. Okay, graph the equation shown below by transforming the given graph of the parent function. Okay, so this one's pretty simple because all I want you to do is type this into Desmos. I'm going to get rid of that equation, and y equals x minus 5 squared minus 5. Y equals x minus 5. Oh, I was not typing. Okay, y equals x minus 5 squared minus 5. I believe that was the correct equation. Let me just double check. Cool, okay, it is. All right, so you're just gonna need to move, I think, like this green dot, and I believe that should be enough. So let's see, where do we want our vertex? This green dot represents our vertex. Vertex being like the bendy part, the part where it just stops going down and starts going up. So where is that vertex over here? You can see that there's already a mark for it, and it is at 5, -5. So move it 5 to the right, move it 5 down. That's all I need to do. Go back to delta math, move it 5 right, and 5 down. And then I just double check. Are the points around it, is there a point at 6, -4? Because there's a point here, 6, -4. I just want to check. So I go here, is there a point at 6, -4? Oops. Right there. Does it look like it goes through it? Yes, it does. So I don't need to change any of my other dots. Everything is good to go here. So 6, -4 and 5, -5. So those points line up and we're good to go. Are there any questions on this one? I guess I should show the equation. Any questions on this one? And then where are we? Okay, interpret exponential function constant. All right, so this hopefully looks a little bit more recent. I kind of remember that it was pretty recent when we did this test. So let's do this one. It says the function f of t is equal to, I'm not going to read that, represents the change in the quantity over t months. Ooh, okay. I think wait, hold on. Let me pause the video. So I'm going to end this recording here and then I'll record again. Just give me a moment while I fix this because this is like harder than the problem I intended to give you. Because that's not going to appear on the final. You're supposed to just have a T. So give me one moment while I fix it.